Rest.
Okay, so in this section, we're going to cover section 1.1, which is talking about linear equations. So let's first dive into this question here. It wants us to solve this. So 6 minus 2x equals 3x plus 1. So the goal is to get the x by itself, right? So we're going to add 2x to both sides. All right. So that cancels out. And we have 6 left over, and then 3x plus 2x is 5x plus 1. Then we subtract b- both sides by 1, and then our 1's cancel, leaving us with 5 is equal to 5x. Then we divide both sides by 5. And then x gives us 1, okay? Which a lot of you got, which is wonderful. So here's my question. What does this mean? Okay. We went through all of this work, and you've probably been doing this since kindergarten. Okay. But what does this mean? It says solve, we found X. What does that mean? Here we go. Okay, so again, this section is talking about linear equations. So first of all, let's dive into what does it mean by a linear in an equation? Well, linear, right, is dealing with lines, right? So if we were to, you know, break this down, it's talking about lines, correct? So you can have different kinds of lines, right? You can have that one that looks like this, or something that looks like this, or like this, or like this. No, not like this, right? So there's different kinds or different slopes, if you want to call it that way, but different lines, okay? And in equations, right? So in this case, um, what kind of well, first of all, when we're talking about linear equations, right, we're dealing with the slope-intercept form, which is y is equal to mx plus b, correct? That is the standard of a linear equation, okay? Y is equal to mx plus b. So in this case, when we look at this equation here, how many equations do you see? How many equations do you see? There's actually two. Very good, right? There are two equations. You have y1, which is equal to 6 minus 2x, and then you have y2 which is equal to 3x plus 1. Okay, so let me pause this. So I have here on my graphing calculator, I've entered the first equation, 6 minus 2x, and the second equation, 3x plus 1. So math math deals with graphs. If you understand the graph behind the equations, then it makes a lot of sense. But if you take these two independently, then math is not going to make any sense. A lot of these, well, all of these equations have graphs, right? So again, if you understand the graph, then you understand the equation behind that graph. So in this case, we know that these two equations are linear equations. They're lines, right? They look something like this, okay? And for both of them, right, this one's a negative slope and this one's a positive slope. So they're going to intersect at one point, correct? So uh, if I were to graph this, okay, this is my first equation, and then there's my second equation. And what happens here? When we solve this, right, we get this magical number, x is equal to 1. But what does that mean? That means when we graph these two equations, that is where they intersect at x equals 1, right here, all right, at that first point. So that's what we're doing, okay? It seems complicated, but it's actually not, not too bad. It's just saying when we solve this equation, we're trying to figure out where are they crossing? What is the point of intersection where they both are going to equal to each other? And that's going to be at x equals 1. In fact, right, you're going to have three different scenarios. And I would write this down if I were you. All right, so, or in this case, you'll have three different solutions. Okay. Okay, so again, I just demonstrated one of them where they're going to cross, right? That's one possible solution. Another one is this one. You might have a graph that looks like this, or you might have a graph that just looks like this. So in this case here, right, these are what? Parallel lines. So how many solutions will you have for this one, for the second one? No. How many solutions will you have for the second one? None, right? Why is it none? Well, they're parallel. Will they ever intersect each other? Never, right? So you'll have zero solutions here. Okay. And then what about this one here? It looks like just one line. Good, right? Infinite. You have infinitely many solutions. So that's why when we solve this, we get like x is equal to 1 because they're only intersecting at one point, which is at x equals 1. This one, maybe when we solve this, we get something like 3 is equal to 2, which doesn't make any sense. Okay, so that means that they're not crossing each other at all. All right. Or maybe we get 5 is equal to 5 at the end. So that means they're both the same equation. Okay. So that means they have infinitely many solutions. So again, when you're going through solving these equations, okay, we're trying to figure out, are they going to intersect? If so, what is that point of intersection, or will they intersect at all? Okay. So this is the behind the scenes, and it's so vital, so important that if, to understand math, in order to do well in mathematics, you have to understand the graph that's happening with the equations. Again, if you think about them independently, this is just a bunch of gibberish. This doesn't make any sense without the graphs. With the graphs, this makes a lot more sense. All right, so again, what we want to do here, we want to solve these and we want to, solve for the variable. For the first one, we want to solve for y. Okay, so we're going to add y to both sides. Again, there's a lot of ways to do this, so this is not just one specific way. All right, but normally if there's a negative, I want to make it positive. So I'm going to add y to both sides. Okay, so then I get 6y plus 6 is equal to negative 18. All right, and then I'm going to subtract 6 on both sides. So that goes away and we get 6y is equal to negative 24. Okay. And then the last step here is we divide by 6. So y will give us negative 4. Okay. Now, what's one way to check whether we got the answer correct or not?
You can plug the answer back in for y into the original
Exactly
equation.
right. Exactly. So let's do that, right? So that's the beauty of mathematics. You can find out whether you got it wrong or right, just plugging it back in. So that's what we're going to do real quick here. So I'm going to check it. Okay, and I would encourage you to do that on the test as well. So if you have time, go back, put those back in the solution, see if you got them right or not. So we got 5 times negative 4 plus 6 is equal to negative 18 minus negative 4. All right, so we have negative 20 plus 6 is equal to negative 18 plus 4. So negative 20 plus 6 is negative 14. Oops. And then negative 18 plus 4 is also negative 14. So both of them we get the same result at the end. So that means y equals negative 4 is a solution to this equation. Okay. All right. Any question on that one? Okay, the next one here, I'm actually going to show you 3 different ways to do this. Okay. So whatever works with your brain. So method number 1, all right, so we have 2/3 x is equal to 9 over 2. Some of you might have just say, okay, I have 2/3 here. I can just multiply by the reciprocal. So I'm going to multiply this by 3 over 2, 3 over 2 on both sides. And then so then these will cancel. and you're just left with x is equal to, and remember when you multiply fractions, you multiply across. 9 times 3 is going to give us 27, and 2 times 2 will give us 4. Okay, so there's one way to do it. Okay, method number 2, all right, is by cross multiplication. So if I have 2/3 x, I can rewrite this as 2x. I can write this as 2x over 3 is equal to 9 over 2. And I can just cross multiply. So I can multiply these guys together and then multiply these guys together. So that's going to give me 2x times 2 is equal to 3 times 9. So that's going to give me 2 times 2 is 4, and I have 4x. And then 3 times 9 is 27, and divide both sides by 4. And we get x is equal to 27 over 4. Okay, so that's another method. And then another way to do it, method number 3, is let me write down here. Okay, method number 3. So again, we have the 2/3 x is equal to 9 over 2. All right, and that's just basically going step by step. So if I have 2/3 x here, I can multiply both sides by 3. Okay, so then the 3's will cancel and we'll have 2x. And then I'll have 9 times 3, which is 27, and then 27, and then divided by 2. All right, then the 2x here, I can divide both sides by 2. Okay, so then this becomes 27 over 2. Remember, when you're dividing, that division becomes a multiplication, and that 2, this is 2 over 1, becomes 1 over 2. Okay, so we get 27 over 4. Right? So again, 3 different ways of getting the same answer. Okay, so again, whatever way works with your brain. All right, and then the last one here, a lot of you are getting, I think, -2. All right, so let's see. So for here, what do we have to do first? What's one thing we have to do first?
Distribute the negative into the parentheses.
Perfect. That's exactly correct, which a lot of people forget to do. We need to do the negative first, right? We have a -1, so we're going to distribute that to each term. That is the first thing we need to do. So we have 7 minus 2x minus 1 equals 10. Okay? That one little choice there makes a whole big, a world of difference. All right, so then 7 minus 1 is going to give us 6. So that's going to be 6 minus 2x equals 10. Then we're going to subtract 6 on both sides. We get -2x equals 4, then divide both sides by -2. Okay? And then so, what do we get here? We get x is equal to -2. So very good. Okay? Again, what we need to do is, once we got our answer, plug it back in, see if we get it correct or not. All right? So I really recommend doing that. All right, any questions on here?